Hello friends, this is Gangadhar from the YouTube channel Maths Ganga. In the previous videos, we discussed the divisibility rules for the composite numbers as well as for different some prime numbers. And in some other videos, we discussed the solutions for the JEE Mains 2018 and then certain concepts of coordinate geometry also. Now in this video, I am going to discuss about the divisibility rules for 7, 11 and 13. Okay, right. And then we are going to discuss the logic behind the magical rule of 7, 11, 13 also at the end of the video. Okay, and I suggest you all to get a command on the divisibility rules to watch the previous videos also. Okay, and do subscribe for the channel. If this video is helpful for your preparation, don't forget to like it and then refer it to your friends also. Okay, let us start with the numbers. Okay, first of all, observe certain examples and I am going to check whether the list of the numbers are divisible by these 7, 11 or 13. Okay, and at the end I am going to discuss the logic, how the logic is working. Okay, let us see the first number. The first number is 314 and 149. Okay, to check whether this number is divisible by 7 or by 11 or by 13, what we need to do? We need to identify the last 3 digits, and after identifying the last 3 digits, we need to subtract the last 3 digits from the remaining number. Okay, from the remaining number. So what will happen if you subtract the last 3 digits? So from the remaining number, 314 minus 149. Okay, now here 14 minus 9 is 5 and 30 minus 14 is 16, 165. Okay, now we need to check whether this 165 is divisible by 11 or 13 or 7. If it is divisible by any of those 3 numbers, then the given number is also divisible by that number. Okay, this 165 can be written as some 5 into, okay, 5 3s is 15 and again 15, 33. And this is nothing but 5 into 3 into 11. This 165 is divisible by 11. Since this 165 is divisible by 11, the given number is also divisible by 11. Okay, if you can't decide whether it is divisible by 11 or not, if it is a number having more than 3 digits, again apply the same procedure. Repeat the procedure till you left with a 3-digit number. What is the procedure? We need to subtract the last 3 digits from the remaining number and we need to check whether the result is divisible by either 7 or 11 or 13. If it is divisible by any of those 3 numbers, then the given number is also divisible by any of these 3 numbers. The same logic is applicable for these 3 numbers. Why it is applicable for only for these 3 numbers and why the logic happens, we are going to discuss the logic behind the magical rule in the at the end of this video. Okay, let us check one more example. So ultimately what we said, this first number is divisible by 11. Okay, whereas coming to the second example, it is given that 8, 6, 3, 8. To check whether it is divisible by the primes 7 or 11 or 13, you need to identify the last 3 digits. And after identifying the last 3 digits, we need to subtract from the remaining number. Here the remaining number is 8 and the last 3 digits are 638 and we are going to subtract. The result is minus 630. And clearly 63 is a multiple of 7. So this 630 is divisible by 7. Since this 630 is divisible by 7, the given number is also divisible by 7. You no need to bother about this plus sign or minus sign. We have to concentrate on the number of prime by subtracting the last 3 digits from the remaining number. If it is divisible by any one of those 3, the given number is also divisible by that number. So 8638 is divisible by 7. Okay, now let us check one more example, and if you see, that was 5, 9, 3, 2, 1, 7, 3. We need to check whether this 7-digit number is divisible by 7 or 11 or 13. Okay, some numbers may be divisible by 2 or more than 2 of those 3 numbers also. Okay, now take the last 3 digits. Do subtract from the remaining number 5, 9, 3, 2 minus 1, 7, 3. Okay, 12 minus 3 is 9. Okay, I borrow 1 and then I have 12. 12 minus 7 is 5 and then I left with 8 minus 1 is 7. 5759. Since it is a 4-digit number, I repeat the process. What is the process? Subtracting the last 3 digits from the remaining number, where the remaining number is 5. So if you subtract 759 from 5, you left with minus 754. We need to check whether it is divisible by 7 or 11 or 13. If you check with 7, 7 ones and 54 won't run in 7th table. So coming to the next number, 11, 6 is 66 and then 94. Then do with 5, 13. Okay. Otherwise, do it. You need to prime factorize it to get whether it is divisible by 7 or 11 or 13. 13 5 is 65. We left with 10. 13 8. So this is equals to 13 into 58. I think so. Since it is 13 into 58, this number is divisible by 13. So the given number is also divisible by 13. Okay. So to check a given number, whether it is divisible by 7 or 11 or 13, we need to subtract the last 3 digits from the remaining number, and then we need to check whether the result is divisible by 7 or 11 or 13. If it happens, then the given number is also divisible by those numbers. Okay. Let us take one more example. And then another example here I mentioned it as 65142. To check whether it is divisible by 7 or 11 or 13, what I have to do? I have to do subtraction of the last 3 digits from the remaining number. It is nothing but 65 minus 142. So that means 142 minus 65 along with the minus sign. So 12 minus 5 is 7. 13 minus 6 is also 7. So 77. 77 is a combination of 7 and 11. So this number is divisible by 7 as well as 11. So this is divisible by 7 and 11 also. 7, 11. In the same way, we can check the last example also. Okay. Sometimes the problem may be in a different manner. Okay. So that maybe they may ask such that we did certain problems having missing digits. Okay. Like this, if anybody mentioned here, for example, if this is some A65A42 is divisible by 65A42 is divisible by 11. Then what is A? If it is the question, then what we have to do? To find the missing digit, we need to do that 65 minus A42, and which is nothing but we need to subtract A42 minus 65, and 12 minus 5 is 7. Then we have here 3, and this is any digit. A is any digit. So since it is divisible by 11, the result also have to divisible by 11. So the result 11 to divisible by we need to place A, and if you place A with 1, 13 minus 6 is 7. Since 77 is divisible by 11, we are able to take 1 in the place of A. And let us check with some other examples also. If you take 2 in the place of A, 24 minus 6. 24 minus 6 is 18, 187. 187, whether it is divisible by 11? Okay, 11 once is 11, 77. So that is also happens. So we can take 2 also in the place of A. Okay, for suppose if you take 3 in the place of A, then we have that 33 minus 6. See, 33 minus 6. 33 minus 6 means you left with 27. 27 and then 7. Whether it is divisible by 11, we need to check. If it is divisible by 11, the given number is divisible by 11 and the value of A is 7. Okay, see, to check whether a number is divisible by 7 or 11 or 13, we just calculate the number obtained by subtracting the last 3 digits from the remaining number, and we check whether the result is divisible by any of those 3, and the given number is also divisible by like that. See, if anybody give you like this missing digit, then also we do the same situation, same procedure. We subtract the last digits A42 from 65. It happens like this. We need to check with the different digits in the place of A. By replacing different digits in the place of A, every time you need to calculate the difference. If this difference is divisible by 11, then you will get. Okay. See, usually for 11 we have a separate divisibility rule. Okay. See, for 7 or for 13, this rule usually helps you. Okay. Now, why the procedure of subtracting the last 3 digits from the remaining number? the procedure is applicable only for 7, 11 or 13. Why can't it is applicable for the other number? Okay, see, I am going to discuss with you. See, for example, take this example, 8, 6, 3, 8. If you have a number like 8, 6, 3, 8, I can write it like 8,000 plus 638. Is it right? Is there any mistake? Correct. And then I am going to write it like this, 8,008. Okay, 8,000 plus 8. Okay, and then minus 8 plus 638. I will write 8,000 plus 8 minus 8 plus 638. This 8,000 plus 8 is nothing but 8 into 1001. Okay, and then here we have the difference. This 1001 is a combination of 7 and 11 and 13. If you multiply 7, 11 and 13, you get it as 1001. So this is divisible by all the three numbers, 7 and 11 and 13. If this difference is divisible by 7, the total number is divisible by 7. If this difference is divisible by 11, the total number is divisible by 11. If this difference is divisible by 13, the total number is divisible by 13. So we need to concentrate about this difference. What is the difference? Subtracting the remaining number from the 3 digits or subtracting the 3 digits from the remaining number. Since this difference is divisible by any of those 3, the total number is divisible by 3. Okay, the same procedure is applicable for everything. Okay, so without doing this total procedure, you are concentrating on the last the number obtained by subtracting the last 3 digits from the remaining number, and we are checking if it is divisible by any of those 3, then the given number is divisible by that. Okay, see, for example, in general, if you have any number, okay, something I have a number having like this, E, D, C, B, A, like this I have a number. What I have to do? Okay, this is a number. I can write this number as some AD along with 3 zeros plus CBA. Okay, nothing is mistaken here. Okay, what I have to do? I will add the total number. Okay, and I will subtract. Up to this ED I will add. Okay, what I have to do in the next step, like ED into 1000 plus the total number along with ED. The remaining number I add. The remaining number I subtract. Okay, since I added, I subtracted, plus CBA I have. Okay, now see, this is the difference what we are going to calculate. Remaining number minus last 3 digits. And if you check this one, this is nothing but up to ED into 1000, and we have one more one, 1001. Okay, see, since this number into 1001 plus I have the difference what we mentioned in the examples, difference between the last 3 digits with the remaining number. Since this is divisible by 7, 11 and 13 always, we need to check whether this difference is divisible by those numbers or not. If this is also a factor, this is also a multiple of those, any of those 3 numbers, then the given number is a multiple of 7 or 11 or 13. Okay, so this is the logic behind the magical rule of the divisible rule for the 7, 11 and 13. Okay, we can check with the examples. Okay, to better understand the logic, you need to move with an example. Okay, what we added, we are writing the number like some along with 3 zeros with the last 3 digits, and I added the remaining number and I subtracted the remaining number. Okay, except the subtraction of the remaining number and the last 3 digits, everything is a multiple of 1001. Since 1001 is a combination of 7, 11 and 13, the total number is divisible by 7, 11 or 13 if the difference is divisible by 7, 11 or 13. So this is the logic behind the magical rule. So this rearrangement of the given number will give us the divisible rule for these 3 numbers. Okay, see, I have the last example, check with that. So now I am going to check whether this 1941797, whether it is divisible by these 3 numbers. I have to check. So what is the logic? We need to subtract the last 3 digits from the remaining number. 1941, okay, minus 797. Do subtraction. 11 minus 7 is 4. See, 3. 13 minus 9 is 4. And then 8 minus 7 is 1. 1144. Okay, see, again apply the same procedure. I do 1 minus 144. 1 minus 144 is minus 143. 143 is a combination of 11 and 13. Since 143 is divisible by 11, 143 is divisible by 13, the given number is also divisible by 11 and 13. Okay, so ultimately what we discussed in this video, we discussed the magical rule for the divisibility conditions of 7, 11 and 13. The rule is, we need to subtract the last 3 digits from the remaining number. If the result is divisible by 7, the given number is divisible by 7. If the result is divisible by 11, the given number is divisible by 11. If the result is divisible by 13, the given number also divisible by 13. Okay, see, why we are subtracting the last 3 digits from the remaining number? For that magic also we discussed the logic. Okay, we expressed any number by removing the last 3 digits. Okay, what we do, we can express it like 1941 triple zeros with 797, and after expressing this we will add 1941 and we subtract 1941, then it will become like 1941 into 1001, okay, plus 797 minus 1941. You left with like this. Always this is divisible by those 3 numbers. We need to concentrate on the difference. Okay, so usually for the competitive examinations, you don't need the logic, you just need the magic to solve. Okay, so memorize the magic, and if you are interested, just follow with the logic. Okay, right. And this is the explanation for the divisibility rules for the 7, 11 and 13. Okay, thank you. Don't forget to subscribe the channel and watch the videos also to get the different magical rules and for the logics of the magics. Thank you.